Today we're going to learn about setting up a base, and this is what we call a random base position for an RTK survey using GPS, GLONASS, Galileo, all that stuff. So the first thing we do is we're going to set a point that we're going to set our base station on, and I usually just set a 6CD nail with a whisker on it, and usually that's good enough. Today I'm going to put a lath next to it just for as an example. And you want to put flagging on it, a whisker, so that people don't knock it down. We always use the same base point number, so we just put base point and then the point number in our file, which will be 50. And then on the back of it I usually write our company name, and that way it's not confused with a property corner. Alright, right here are all the components to do the survey for the base station. So we have a data collector, our GPS units in here. This is our battery, and I have it in a kind of like an ice chest kind of thing to keep it from being damaged by the sun, overheating. This is the tripod. First thing we're gonna do is set the tripod. Keep the legs together, pull the tripod up about 3/4 of the way. Give yourself about a hand space. Don't extend the legs all the way. Then this leg here, the leg that I'm going to face my optical plummet on, I want to face north-ish every time I set it up. Now, you don't want your legs too far apart. Some guys like to do this and set them out really far. That's good for the wind, but it's really hard to center your tribrac over legs like that, because every time you move the legs, it's going to move a large deal horizontally up here. So I just look over, try to more or less get it over the nail. Then the next component is your tribrac. This is a tribrac. And this tribrac has an optical plummet. That means I look in here and it looks 90 degrees straight down. And as I look through this optical plummet, I want to be looking north. And so when I look through here, I see that it's just a little bit off of the head of the nail. So I move the whole assembly over, and then I stick the legs. When you stick the legs, push parallel to the legs. Don't push at an angle where you're pushing down. That won't set the legs well. It also can bend if you're using an aluminum tripod like this. It can bend the legs. So now after I've set it, I level it just a little bit. I'm going to try to make it exact. The next step is to center the crosshairs or the centering mark over the center of the nail. You might have to bend the whiskers out of the way so you can see it. So now that it's centered, now I want to level the tribrac. So the method is center it first, level it next. Now when I level, it's not going to move that much. I go ahead and fine tune it, then I check it again. I unscrew the tribrac without rotating this, and then I slide it over a little bit to be exactly centered on the nail once again. I check the level, check it, everything looks good. Next step is to take the base unit, attach the portion that will attach to the tribrac to the unit, turn it on, place it. The face of this is facing me, which is facing south, so the rear is facing to the north. Every time you use a unit, always set it up in the same direction, because the phase center of the antenna in there for GPS isn't exactly centered. So whatever that offset is, you want it to always be relative to your setup point. That way it doesn't introduce error. Next component is the radio. This is a long range UHF radio. Some units have built-in radios that are also UHF. Some of them are Wi-Fi based. This one I'm using UHF. It's kind of my go-to that gets me 6 miles of a radius of radio broadcast, so I can work quite a ways away from the base. This is the antenna. This is a short range antenna. This is the long range antenna. I'm not using that today. This is the rover. So I go ahead and set this up right now. and set it on the truck. But I'm just going to set it here for the moment. Next step is you want to measure the height. On this unit, this is a Topcon Hyper Plus. We measure from this plane right here. So I can rotate this a little. Look at my laser. Take the measurement 417 and record that in your field book. Now, the last part about setting this unit up is hooking up the battery. You never want to put a battery on the ground while you're working. The way batteries work is they work with two different polarities, a positive and a negative. And when they're grounded, they'll want to send energy into the ground. So if you set a battery on the ground all day, it'll go dead. So you want to put some space, some insulation between the ground and your battery. And so we put it on top of our case. And that will make the battery last all day. It won't put any of that excess energy into the ground. So now at this point, I just make sure my radio's on. I'm going to be doing a survey very close to the base, so I'm not going to turn the long range mode on. I'm just going to leave it in short range. And that's setting up the base physically. The rest of the work's done on the data collector, but that's how we set it up. So now I'm going to go ahead and start the base. This base uses Bluetooth connectivity, so I don't have to hook a cable. I'm going to go into the survey menu, start survey, choose the unit. This one's Hyper Plus base. It connects to it with that sound. Hit connect. It's going to do some more communication. Enter my instrument height that I took, which was 4.17 feet. And then I'm going to tell it to do post-processing, which it means as it sits here while I'm surveying, it's going to just keep collecting shots every 5 seconds on where it is. And I can upload that data to the National Geodetic Society and then get a precise position on this nail. So it'll give me plus or minus about an inch vertically and plus or minus about half an inch horizontally. Then I tell it what base point I want to use, and I'm going to use base point 50. And I'm selecting the option is base is set on a new job point. And that's usually what we do unless we're working off of an existing file. Then I go ahead and say set rover. If you say finish base setup at this point, you'll have to manually configure your rovers one at a time. And that's usually in a situation where you're using multiple rovers. Now in the next screen, I select my RTK rover, which in this case is Hyper Plus 3. Before I leave the base, I check that the TX light is transmitting on the radio and the RX light is not. If the RX light was flashing, that would mean this is receiving radio data from another base station, and that's bad. That means someone else is broadcasting. But because only the TX light, the transmit light, is flashing, I'm the only one in the area working right now on this frequency, which is what you want. So now I'm going to go over to the rover, connect to it. I'm connected. And what it's going to do is going to say, do you want to do a static position on this? And I'm going to say no, turn that off. I'm going to enter my rod height, which is always 6.89 because I use a fixed height rod with this rover. And I hit next. My radio is saying it's getting 100% reception. It got the base. And then I'm going to go ahead and say start now instead of collecting control. Now, the last thing I have to do now that I've started, I want this to be a ground survey, and I've set this up to start using mapping plane. Right now we're in New Mexico West zone, and I'm going to go ahead and go into survey projection and go and hit the mapping plane ground button. I'm going to say use ground coordinates, pick a point to define the origin. That's going to be the same as my base point, so point number 50. Then I'll hit next. it's automatically calculating me a ground scale based on my ellipsoid height from the autonomous position it took. I'm going to accept that, hit next, and then I'm going to copy the northing and easting that it's displaying into the desired local ground coordinates, because I want basically the northing and easting to be the same at the base that it calculated for this area of the projection. So just copy that. When I hit next on the screen, it should give me a 0 difference between the coordinate values if I copy them right. Okay, I'm going to hit finish, and we're now in ground instead of grid distances. We're still in grid north, but that's okay. We can change that in the office if we need to. We're going to add all the improvements on this job based on an aerial survey. So we both do ground survey while we're out, but we also set what are called aerial panel points or targets with our little template that we made here. And you just take white paint and fill in the 2 areas, and it leaves you a little checkerboard like that. And then I'm going to take a shot with the GPS right there in the center. An easy way of finding a point, and not struggling like this and trying to find the center and stab it, is just put your heel up, use your toe, find the spot. And then we always face north when we're taking higher accuracy shots. That way, if there's any error in your rod, it's all in the same direction, so everything's off the same amount in the same direction. So now I'm going to go into data collection. We store the panel points in 0.100, starting at 0.100, and we give them a description of P and L. And we do a shot that takes 4 or 5 observations once it's in static mode. Static means you're not moving, and those are higher accuracy shots when using GPS. There we go, and store it. I'm going to set about 6 of these on this survey because the parcel's kind of an L shape. So I'm going to set 2 on the north end, 1 kind of in the southeasterly, and then the rest of them around the project. Okay, so here's our first starting corner. It's already identified, easy to see. Right here I see that there's this rebar, and that could easily be mistaken for the corner. This is most likely not the corner if it's sticking this high above the ground. No surveyor I know would actually do that. Most likely the homeowner did this, or a real estate agent. The actual corner is going to be down here. So I take my shovel out of my man purse here and dig down. Surveyors like to tie a lot of flagging on to guide you in the right direction. This specific rebar, it's a 1/2-inch rebar. It's got a tag, it says NMPS 12129. That tells me which surveyor did this. In this case, it's David Sen in Truth or Consequences. Now, usually what we do is put a lath next to these that says Prop CNR, and that's just an abbreviation for property corner. And we put this right next to and behind the actual rebar, or whatever they use to mark the corner, just so that the homeowner, landowner, can easily find the point and not mistake it for the witness corner. Then I'm going to go ahead and observe this point, again, facing north. And I'm going to try to determine which point this point agrees with in my file. So I go ahead and zoom in on my point group, which hasn't been translated to the local area that I'm in. And this is point number 5005. So when I observe this, I'm going to put a 10 in front of that 5005. So 105005. And then I'm going to say what it is. In this case, it's a 1/2-inch REB for rebar. TG, that means tag, and then 12129, which is the surveyor's identification registration number. And I'm going to take a higher accuracy shot on this because it's a property corner, similar to the panel point we just observed. Go ahead and store that. Now, what I'm going to do is translate the group of working points that I made before the survey. So I go into Adjust, Translate. All of our calculated or COGO points, which stands for coordinate geometry, start at 5,000 and go to 5,999. Now there's not that many points, but that makes it easy for me to select a point range. And right now I'm telling it, give me all the points from 5,000 to 5,999. And I choose that point that was related to the point that I just shot, which was 5,005. And I tell it to move it to 10,5,005. And then I hit solve. And it just moved that entire group of points and locked it into that point that I just found. So now I can stake out to my next point, which would be down that way into the desert. In my bag here, just so you know, this is a metal locator for ferrous metal, which means magnetic metal, like iron. This is my little shovel. I've got extra lath in here for marking. I've got my sledgehammer. And then of course I've got my flagging, my field book, and you always have to have a marker on you. You don't have to wear a vest if you don't want to. It just makes things easier and safer. You don't have to have a bag, but you should probably have all these things on you if you're going to be surveying by yourself. So let's head to the next point. Okay, so now we've just gone to one of the next corners. I'm going to go ahead and stake it. I can see this point. It's the same type of monument that was set for the last corner. Why don't you come in here and I'll show you what a tag looks like. This is an impressionable aluminum tag, and you can see the surveyor's number on there. NMPS stands for New Mexico Professional Surveyor, and that's 12129. That's his registration number. This is a rebar. This is very standard for what is set in New Mexico. Sometimes there's a plastic cap on it with the same information. So I'm going to go ahead and I'm staking out to what this should be, but there's something else going on. I'm in grid north, and I said that at the beginning, which means that I'm not in true north. Grid north is very, very, very much different than true north. It's off in this location about 12 minutes, and that adds up to a lot over the amount of feet that we're going, which is about 200 feet away. And right now it's saying I'm 1.29 feet off, but I'm really not. So we're going to get rid of that rotation here in a second. I'm going to go ahead and store this just like I did the other one. This is the design point 5007, so I'm going to save it as 105,006 or 105,007, but I'm just going to say 10,5,007 because it makes it easier in my mind. It's going to have the same description as the last point. Store that. Now that I'm done with that, I'm going to go back into my adjust menu and go and select rotate this time. My rotation point will be the point that I moved everything to the last time. So I go ahead and say, okay, tap the point, select point 5005, and then I'm going to select the radio button that says I'm going to rotate based on old and new azimuths. My old azimuth, I'm going to choose from map, will be 5005 to 5007 because that's the point that I found. Then my new azimuth will be 10,005 or 10,5005 to, and I do that with the hyphen, so I abbreviate that with the hyphen to 10,5007. That gives me my new azimuth that it's going to rotate this to, and now all of my other points should be really close. Go ahead and solve that. And now I can inverse, which is checking the distance between 2 points. And the 2 points that I'll inverse are going to be 10,5007 to 5007. So let's see what that is. 5007 to 10,5007. Solve it. 62,000. So 0.062. That's just a little over half an inch. So that'd be like 5/8 of an inch. And I go ahead, this is already flagged up really well. I'm not going to waste another piece of wood right here. This doesn't make any sense. But I will put some new flagging, which is the same thing as saying, I was here. It tells the client you actually did your job. So the next thing I need to do is set, this is an interior corner of the L shape, so I want to set a panel right here, but I need some paint. So put a mark here, just something that I'll be able to see from the air. So that's an intersection. I'm going to put something semi-hard in the middle so that my rod doesn't go into the ground. Shoot that there. So my next point number should be 101, since our first one was 100. And again, with the description PNL. Go ahead and observe this for a couple seconds. And there we go. At this point, the rest of the survey is going to go really easy. It's going to be the same thing that we've done at every corner. I've already gotten rid of the rotation, so we're going to be here for another maybe 20 minutes. But the next phase that you'll see is the drone flight. Okay, so now we're going to set up the drone. We finished the ground survey. We've set all the panels, shot all the panels, found all the property corners, found a tie. We also realized that I've done the survey right next door already, so we have even more information. This is the M300, DJI M300, and the way the box is set up is we have the legs over here. Basically the landing gear are just legs that are permanently fixed. So I take it out and I can slide it into the right place, into the receiver, whatever you want to call this. Line up the locks. I like to put the camera on when the drone's upside down. It's much easier. So take off the cover, take off the cover on the camera, line it up, hold your mount so that you don't put extra or undue pressure on these shock absorbers here. Now the drone's lighter than it usually is because it doesn't have the batteries in. I grab both the legs, then I'm going to go ahead and insert the batteries, and I can take my lens cover off at this point too. It's a good idea to cover your close your cases when they're not being used, because when the drone takes off in close proximity, it's going to scatter dust everywhere and it'll go into your cases. So try to keep them shut. Now, 2 batteries. Always check that they're at least the same charge. These are both flashing 1 low, so they both have the same rate. Hold the front of the drone while you insert so you don't accidentally tip it over. Lock the batteries into place. Then we can take out the wings. If you've already seen this before, no biggie.